bottom, this will be up to date when it's fully functional. And in the middle here, in this bar chart will be the today's daily fluence, 3 days in the past and 4 days in the future. Along with the thresholds being set, as shown here on the top of the screen, for moderate events and extreme events, 20% and 2% correspondingly, the bar chart will be colored accordingly. Yellow for moderate events and red for extreme events. In the future, when full functionality has been achieved, a user can set their own thresholds, the 20% and 2% as shown here, to accommodate their own needs. This will be done via the button here, set thresholds, and they will be different for each orbit. But this has not been implemented yet, but it will be implemented very soon. Here on the top of the screen, there's a quick user guide that explains all of this in more detail and how to use the service. And there's also here this piece of information that says when the last update has been done and which data have been used to produce the bar charts and the CDFs. So going further, for each trajectory, a user can see more details about the trajectory selected, the orbit, and this will be done with the View CDF button. It goes a level deeper, and here we can see more details about it. It's the orbit being selected. It's the same bar chart with the same values, and along with it comes this gallery of CDFs. There's a CDF corresponding to each day on the left chart. You can see here for its date. Here on the top, there are the thresholds being used. For now, we're using the default thresholds for 2% and 20%, as said earlier. And on this CDF, we have overplotted the distribution of electron fluence for each day. The black star is the median, and the red and green line correspond to the 25th and 75th and 5th and 95th quantile, respectively. This happens for all orbits. As you can see, we can return to the homepage and view another CDF, and this is for MEO. It's the same thing with a different bar chart. And for the MEO trajectory, there's also a link to the GNSS Galileo support that Ingmar and the rest of Spark will talk about later. And this is the main functionality. What remains to be added is login and registration for users. So any user can can set their own thresholds, so they can get more relevant results, and they can also use either percentages or absolute values for the fluencies to represent. And yes, and the actual setting of the thresholds. And this is pretty much it. I'm going to leave the sharing up for a bit if you want to ask some questions.
Thank you, Stefanos. Any question up to now? Any comment?
Could you just show me the daily CDF again? I didn't quite understand the overplotting. Say for the Leo. Yes, this is one. This one.
Yeah, of course, the CDF is always the same because the CDF is based on historical data. So the curve is the same, but what changes are the points for the 7 days on the curve. I mean, we see where every day the predicted fluences are located along the curve. Stefan, maybe you can just click slowly and change from one day to the other. So you can see that the points move along the curve.
The red part is the 7 days?
Excuse me?
Sorry, again, I was asking if the red part, the red segment, was the 7 days prediction with the stars in between, or?
The prediction is for 4 days because the 7, we have, you can see the date. Well, it's not really, maybe we should indicate, Stefan, and maybe we should clearly indicate on the left chart, we could put the word today. So,
yeah,
so
Yanis,
yeah.
Yanis, I think Dominic was asking what are the red point on the CDF.
Sorry, I
and
didn't
the grid ones. So
Yes,
the,
yeah, thanks, Sebastian.
so this is because the tool we have implemented into SafeSpace gives us the uncertainties in our predictions. So the black point is the median of our prediction, and the two the red points and the green points give you the distribution. So the red points, the left one is let's say 75th percentile, and the other one is no, sorry, let me, yeah, the red is I read again. Yeah, the red is, okay, the left-hand side of the red is 25th percentile, and the left-hand side is 75th percentile. And the green is 5th percentile, the one on the left, and the one on the right is 95 percentiles. So you can imagine a Gaussian, if it is exactly Gaussian, a distribution where the black point is the median of your Gaussian.
Okay, I think the Gaussian is a better representation for me. But
Yeah.
Yeah,
Okay.
so it tells you the uncertainties that we have in our prediction.
okay, okay, it makes sense. Thank you, Sebastian. On the threshold you can change is only in terms of percentage in time. Huh? You are not changing the threshold of your
You could, because the way we plan to implement the user's values, if you set a percentage, it will tell, for example, here top 2% means that on average, you will not get a red alarm more than 2% of time on average. If according to your payload susceptibility or so, you may think that you do not have an event 2% of time, but 1.2% of time, then you can change this percentage. Because we have the full distribution function, so which is the red curve on the right-hand side plot, if you give the percentage, it's like giving the y-axis, and we will compute the threshold value corresponding to your percentage. So in reality, you could either set the threshold value in terms of daily fluence or in terms of percentage, and we will compute the other variable corresponding. Am I clear?
Yeah, I think so. It makes sense. It makes more flexibility, but it makes some reiteration to define the correlation between the percentage and the real.
Yeah, in fact, this was set up because some years ago I was talking with after-sale service from TAS, and they came to us for space weather service at GEO because the services at NOAA was raising too many alarms, and they claim that when there are too many alarms and they do not see any event on the payload, they just don't look anymore at the alarms. So the service is useless. And they ask us to provide them an alarm no more than 2% of time. So this is how this 2% came up.
It makes sense. I fully agree. This massive number of information will kill the system, so we have to focus on the rare events to be able to react.
Exactly. And making it flexible to the user, you can just adapt, because we cannot produce an indices which is available to any spacecraft payloads, because the design is different. So you have to customize to your own mission.
Probably it will be interesting to talk in a second step, because the fine-tuning of this parameter will be pretty tricky, because of the rare number of events and the correlation with the threshold. I see a bit of a tricky setup of the tool after. What do you think?
Yeah, to tell you, we did a first demo on Wednesday, and we got a requirement from Simon Plum. He told us, okay, it's nice to be able to change this threshold or the percentage, but we need a rule. So how do we change it to make it more appropriate to our payload? And this is tricky.
Yeah, it is exactly what I was.
Yeah.
saying.
So I
So the
just
fine
mentioned.
tuning, which is a definition of use threshold on
Yeah.
parameter, right? It will be to me very complex to set up in correlation with the orbit on spacecraft technology.
So my first thought looking at this is at the beginning of when you have a new spacecraft in flight, there is a learning curve for the users, for the operator, on looking at the behavior of the spacecraft and try to understand its real sensitivity to space weather. So, and I don't know, this first 6 months of life is enough to correlate any events with various threshold, and then you can put in the appropriate threshold for the rest of lifetime of the spacecraft. I don't know if 6 months is enough, may not, depend.
Sebastian, can I ask a couple of other questions? So this one that we're looking at the moment is for LEO. Is that specifically Poe's definition of LEO, or is it some generic?
Yeah, it has been done according to Poe's because we have a long-term data to produce a distribution function. But if there is an event, an alarm set at Poe's, it is available at 2,000 kilometers altitude or whatever. The environment relatively behaves the same.
Okay.
The flux will be higher at 2,000, but again, here it is done according to Poe's, so it will be available to any LEO.
Yeah, I think it would be really useful to see, I don't know if you have it, some examples of historical data where you've gone into the amber and red zones for LEO. I don't know if you have any of that available.
There should, because if we look at the distribution we have, we should.
Of course, yes, that comes from the data. Yeah,
exactly. We should retrieve all the data in the distribution which are in the red box.
Yeah.
So if we look in the database we've been using, we should find the dates for those.
Okay, that would be interesting, I think.
I think that's beyond the scope of this activity, but something could be interesting to do is to have a real event database, so let's say a GEO or MEO, whatever, and try to make the best correlation with this kind of indices we are producing. Which threshold should we apply to raise an alarm when events have been seen in real life?
Yeah.
Sebastian, may I ask you a question also, maybe in complement to what you said? Because yes, this is very interesting and this is a good proposal. And I was wondering if you were able to reuse the old data from METOP when we were working together on to see what you can derive from it.
Here we concentrate on electron data. So we can only have good correlation with electron-induced event. And
which
in
is
the
a
case
limitation.
in the case of METOP, it was single event upset and it was protons.
Yes.
So if we could set the same thing
my
with
second
protons.
question.
Yeah, Dominique?
No, please. I'm sure you know my second question already.
Go ahead.
Well, no, for METOP, the missing information of protons, because you are only covering part of it.
We could do the same kind of statistics with the same data available on METOP and perform the same kind of alarm. The difficulty with METOP and protons is you will get an alarm every day. Let's say at every South Atlantic anomaly crossings.
Yeah, but does it mean we exclude these analyses? We only focus on electrons in your approach, or because do you think we are protected against protons?
No.
Typically, for the South Atlantic anomaly, on.
If we think in terms of space weather, we are looking at time variations in fluxes. And the South Atlantic anomaly does not really vary.
Mhm.
It is high flux, but stable.
So that's why it's a bit out of the scope of
Yes.
of this.
Yes.
Just to make it clear, I know we had some discussion already in the past, but just to make it clear. Yeah. Okay. And I guess this discussion with applicability to some spacecraft technology will be discussed after in I don't know, it's the last for package for the users. That's something we will address later on.
The protons will not be addressed in this activity.
No, it's understood. But for the discussion with the space industry, to see the applicability on iteration with the definition of threshold, actually with them.
I could not hear the end of your sentence. Sorry, Dominique.
No, it's my macro. I don't know. There was a metallic sound before. Is it better now? Because I'm just.
No.
No, I have the macro in front of my mouse. I cannot.
It goes up and down.
Maybe if you put a video, you can read on my lip. Okay, I will try to. Is that
That's
better?
better now. Yes.
Yeah. Okay. No, I was just wondering on asking about the next step of the work package with the discussion with industry. If you think we will get more tangible results on the applicability to this service.
Well, we expect several feedbacks. The first one feedback, of course, is does this kind of product and the way we provide the service is convenient for end users? This is one of the main questions. Having in mind this one address internal charging effect on spacecraft. This is the first thing. And also at the end of the project, will be interesting to have your feedback on if this logic is fine, what's missing to space in industry end users to have a complete space weather service for their purpose. We know we will not address everything in this task, but your feedback is interesting, and the philosophy of the service, if it complies with the way you work and etc., you will use it. If it is fine, should we add more details? Should we explain more, etc.? So all these kind of feedback are interesting to us.
Mm-hmm. Could we use what you have already in place and apply to Copernicus Sentinel, for example, just to play with it in coordination with you? Because the best thing is to use it and see what we can get, the different correlation, and how it will prove it. And then we will be able to give you better feedback.
Yeah, we are of course open for discussion. We can look with historical data that we have, that the one we have used to do the statistics, and my Greek friends will set up the full services and to have it operational in the next few weeks. I would say by mid-June it should be up and running. Okay. So we will also iterate with you, of course.
You know, we are keeping trace on of all events, relation events, on all spacecraft. Sometimes you can correlate, sometimes not. So maybe if you could tell us what you need, we could give you this information in order to make a concrete case, maybe on the service. That's
okay.
could be
sounds very good.
Could I just ask, just before we move away from this, could I just ask a couple more questions? Sebastian, your comment about stability of the South Atlantic anomaly for protons is the same true of electrons?
No.
There's much more variability. Okay. Good.
Yes.
So
what we know now is there is no energetic electron belt in a belt, let's say, and what I mean by energetic is greater than 700 or 800 keV electrons. But there are very extreme events where we are transient electron belt down to the Earth, and they stay there for a few months and disappear after, let's say, 3 to 6 months. So we have a couple of examples. We have March 1991, and we have others in early 2000s. But it's a real transient. So there is no stable electron belt in the South Atlantic anomaly. but you may have a transient one.
Okay.
So very different from protons, yes.
Yes, and the other thing is if we talked about seeing this right-hand chart maybe for some historical events of interest. Would they be that 1991 event and Halloween storms, or would they be also days on when there was more precipitation into the polar region?
Yeah, I should look in detail, but I'm about sure we are in the red box. The most intense events are in 2003 and 2004,
Yeah,
and 1991 is there. But in the historical data set, we do not have 1991 in all data set. At MEO, we do not have it. In the LEO, we have it. And in the GEO, we don't have.
Okay, but for LEO, apart from those extreme events, 1991, 2003, what is it that causes us to go into the yellow and red? Would it also be when there's increased precipitation in the polar regions?
No, I don't think so, because
that's not so visible.
No, because precipitation is on a very short time scale, and here we are looking at daily average. So
Okay.
It's not due to precipitation. It's really trapped particles, and an increase in fluxes from the trapped particle population, not precipitation ones.
Okay, thanks.
The high flux from the precipitating particles, they would be more important for surface charging at LEO.
Right, exactly. Yeah, yeah. And so that's something actually that's of great interest to me, surface charging. Any ideas about how this kind of approach could be extended to, well, not just surface charging, but maybe the charging of charging that's not surface charging, because photo emission is not important, but it's not deep in the body of the spacecraft. Maybe 200-300 kV, less than 800 kV being important. Just beyond blankets, just through blankets, say.
Yeah, so you would say intermediate charging, let's say.
Yeah. Shallow.
So I think we could apply the same approach. This approach could be applied down to 300 kV electrons. It is reasonable. Below 300, you have a strong MLT dependence in fluxes, which has to be taken into account. And again, it is more precipitating particles which are important. But in the range you mentioned, we could apply exactly the same approach. Yes, it makes sense.
Okay, thanks.
Okay, so maybe then if there is nothing else for now, we could move to the Galileo service. Ingmar.
Yes, hello for me. Give me 1 second. So, in the framework of this activity, we had prepared a dedicated work package in order to provide an additional SafeSpace product dedicated to Galileo mission. So our first, let's say, attempt will be presented today with this demo. So we have created a dedicated web page, which will be part of the SafeSpace main landing page. And we present essentially 3 plots that are going to be updated on a daily basis regarding the forecast and regarding the near real-time basis of Galileo satellite, as long these are available from the Galileo Science Data Center. So the first plot, as you can see, I hope, through the WebEx, presents the latest available measurements from the Environmental Monitoring Unit on board Galileo Satellite 0215. We have also the opportunity to provide similar measurements from the Galileo Satellite 207. Nevertheless, we don't expect to have significant differences or deviations between these measurements. So we think that it's more convenient to limit ourselves to the presentations from one satellite. And the second plot and the third that I will show you later, okay, it's more important and more relevant to the SafeSpace activity. So this plot at this moment looks a bit complicated. I will try to describe what we are viewing, and your feedback will be very welcome. So in this plot, what you see with the black points, black lines, corresponds to the latest measurements of EMU. We have selected for this plot a characteristic energy of 0.3 MeV for the electrons. What you see with the yellow color corresponds to the values of the forecasted fluxes within the margins expressed from the standard deviation of the distribution of the measurements that are predicted by the SafeSpace service. What you see now with the blue lines corresponds to the orbit averaged measured fluxes by the EMU. What you see with the red lines corresponds to the orbit averaged predicted forecasted fluxes from the SafeSpace activity. And just to provide some additional indications regarding the level of the observed and the forecasted fluxes with respect to the time history of Galileo satellite orbit environment and with the respect of the standard radiation environment model which the community uses. We have added with the horizontal black dot dashed line the mean value of the AE8 model, and with the red horizontal dashed dot line, we have provided the maximum value at this energy that has ever recorded from EMU monitor on board both Galileo satellites that I mentioned before, 0207 and 0215. So from what we can see here, this plot was created 3 days ago. We're not on the operational mode at this moment. What it's interesting is that, at least for this limiting case, we see a kind of natural, for the time being, continuation of the measured fluxes through the forecast provided by the SafeSpace outputs. And similar plot or similar discussion also can be made for the second energy channel that we have selected to provide results. And this is the 1 MeV energy channel of EMU monitor. So again, you can see with black lines the latest available measured fluxes by the EMU, and with the yellow ones, the forecasts for the SafeSpace activity, where more details about those were presented before. So this is for me. Regarding the Galileo service, it will be interesting to receive a feedback if these are the properly selected energies, or maybe some additional energies can be also included, which means we can include an additional plot. And in the same style that we have presented a relatively near real-time comparison of real data and forecasted data, if it is needed from the community, we can do something similar and for geo orbit by taking into advanced either real-time gauge data, either NGRM data, which is on board the geostationary satellite EDRS-C. And for the long future, this is not possible to be done now. Just to comment on what was discussed before by Mr. Montero from EUMETSAT regarding Sentinel satellites. It is expected within the next months to have near real-time measurements available from the NGRM monitor on board Sentinel-6. It's a Copernicus mission. And potentially in the future, this service can be extended to address particular needs for Sentinel satellites, Sentinel orbits. That's all for me. Any question and any feedback of yours will be highly appreciated. Thank you.
Thank you, Igbar. Any comments or questions?
I think it's really nice. I really like actually the dotted red line with the maximum values. I think that's a useful feature to put things into context.
Thank you.
Maybe a question. Are you applying the same philosophy with the probability of raising alarms, or how will it be materialized with a search prediction?
Can you please repeat the first part at least of the questions, because I was not able to hear it?
Okay, can you hear me now?
Yes.
Yeah. I was asking if there was some similar approach for raising alarm based on these indicators, based on the probability or maximum of alarms you want to receive. Because I don't see the parallel between the previous indicators,
Okay.
alarms.
Yes, no, these products are completely complementary with what was presented before. We don't raise any alarms. All the alarms at the GNSS MEO orbit can be raised or can be set up by the user using the tool that was presented before. However, that tool was based, and it is based on the daily fluence. What we're trying to do now, we're trying to make comparisons of real-time data and forecasted fluxes, not on a daily basis, but based on actual measurements and on forecast projected on the cadence of the EMU unit. It is not possible to raise an alarm based on actual EMU measurements, given the fact that we have a time lag between the measurements of EMU and the time that we are able to access them. And this time delay does not depend on us, depends on Galileo data center.
To complete the comment, is this part of the service is more dedicated to expert users who wants to dig a little bit more in the dynamic of the space environment. All users are not comfortable with fluxes, with high cadence fluxes like shown here. So this is more to address end users' requirements.
So, any other thought? Okay, let me here comment that we will prepare a really short questionnaire in Google Forms, and we'll invite you to share with us any additional thoughts or suggestions, requirements. We will have a very small number of questions and we'll send it to you. Furthermore, we will share with you both the slides from the introduction and the recorded session. We will make it available. And we plan, as I have already announced, we plan a hands-on session of the service in late September. We will update you when exactly it will take place, probably in the beginning of the last week of September. It will be organized with in person here in Athens, and we can support your trip to this meeting. We hope that you will be able to come, and we will probably perform a doodle questionnaire for the ideal day for this. Okay, other than this, we will of course inform you when all functionalities will have been implemented into the website. We will send you the URL so that you will be able to play with the tool if you wish so.
Yeah, should be nice. I have another question about this initiative using Copernicus Sentinel-6. By when did you say you will start this additional data usage?
Okay, this is an activity of European Space Agency. So this data, I can understand that they will become available maybe from December of this year. But such a service within the SafeSpace activity has not been prepared or thought in advance because we were not aware at that time in the past that we could have this possibility. But within ESA Space Safe project, yes, and within the ESA SSA portal, I expect December or January, the Sentinel-6 near real-time NGRM data to become publicly available.
Okay, but we have access at EUMETSAT to the data because we operate the spacecraft. So we could,
Yes.
I could also anticipate some sort of basis on it.
Thanks.
Okay.
See, I see a message here. Oh, okay. Yeah, it's a message by our project officer. He logged in. Okay. We had for a little while, our project officer attending the demo. Okay. I didn't notice. He's just sent me a personal message. That's good. Okay. So any other comment or question or yes?
Yes, so the website, when you have it, clearly the things you want people to look at most are the forecasts and that the user directed impact pages, shall we say. But will you have any sort of additional secondary, more detailed plots on there? For instance, I'm quite interested in the plasma density forecasts.
The plasma density forecast is already available.
Okay.
So yeah, it is a daily. There is a daily update. Fabian, maybe would you like to say a few words on that, since it is a product of BIRA? Yeah. Fabian? Okay, we cannot hear you, Fabian. I don't know why. What I can do is to include an additional slide in my introduction to give you the URL for the plasma density prediction. Okay?
Great, thank you.
You're welcome. Okay, I'm taking note of this density prediction. And we will also, what we do not have right now, but we will also add it, is to show the predicted KP index, which we use. The graphs are not displayed yet, but we have it, of course, and we will just include it also.
Can you hear me now?
Yes.
Okay, sorry. So there is a web page hosted by Andrei Santolik, where all the simulations of the plasmasphere density are available. It's only animations and plot. It's not data files, but if you are interested to more, you can contact us at Biora to have more information. But there is a web page with all simulations and forecast given by the plasmasphere model on a web page. I can try to share it, but
Ingmar, maybe you can stop sharing so that Fabian can share his screen. Okay, thank you.
can you see it?
Yes.
Yeah. So here you have some explanation about the density, plasmasphere density model that is included and used in SafeSpace. And here you have the ensembles of the simulations, and I can click on it and you can see that you have the 4 days, 5 days until today. And if you check today, so probably it has been run not today, but a few days ago, and you go here and you have the electron density at 4 different latitudes, and the plasma pose forecasted by the model around 4 in black here, and as a function of ML at that time. So it's today at midnight. You have all those plots available on this website.
Okay, thank you. And is that, I can get access that, can I, or is it locked behind some?
No,
Is it internal only?
no, it's open. It's
Okay.
we can send you the web page. It's a general web website. Santolik and his team with several other informations about the project, the link to the SafeSpace page and the density model here. And there are some movies also here of the simulation. Maybe
I must say the newsletter is very nicely done because we have access to all the information on the planets. This is my summarize to better understand the scientific part, which is your So thank you for the newsletter. Please carry on.
Thank you, Dominique. We are very happy that you like it, and thank you for your kind words.
So here you have an animation of the simulation, and you can see that the plasma pose was evolving, and there was a kind of plume created for this event. So all those pages are free available, free accessible from the Czech website, and we can send you the link, or if you can look at it now, you can just directly go on it.
Okay, thank you.
You're welcome.
So just a short comment here. There is no updates since Wednesday because due to the very hot temperatures that we have in France, and especially in Toulouse, I tie wrap, so I've got the cooling system get down and the computers running the services break down. So we have no new update for solar wind propagation since Wednesday for the SafeSpace, but well, it'll be up and running next week. This is real life.
So So that's why the simulation started a few days ago, and the forecast was until today only, and not 3 or 4 days as it should be.
So I think this brings us to the end of our session today. Thank you very much for being with us. We will keep in touch with you and provide the items we have already mentioned. And please feel free again to share any other thoughts that you might have, especially when the web page will be fully functional. But we are really looking forward also to welcome you in September for an in-person interaction in Athens. Thank you very much.
Thank you to you. Have a good day. Bye-bye.
Have a good day.
Bye bye. Thanks a lot.
Thank you.
Bye.
Bye-bye.
Have a nice day.
Bye bye.